Welcome back to another video. In this video, we're going to talk about how in the world do you graph rational functions. So remember, a rational function is a function that is a fraction that has a polynomial in the numerator and a polynomial in the denominator, and the denominator cannot equal 0. So we're going to talk about how do you graph those. So I'm going to give you 7 steps. I'm going to list them out here. Then I'm going to walk you through an example on how to use each of those steps. So step 1, what you want to do before you even start, you want to make sure that your fraction is reduced, simplified as far as it can go, meaning it's written in its simplest form. So if you have anything that can be factored, you want to factor it out and see if anything can cancel. Once you make sure it's in simplest form, you want to first find the vertical asymptotes. You want to second find the horizontal or oblique asymptotes. Then you want to find the Y-intercept, and you find the Y-intercept by letting x equal 0 and solving. Then you want to find the X-intercept. You find the X-intercepts by taking the numerator, setting it equal to 0, and solving for x. Because if the numerator of a fraction is 0, then that fraction equals 0, as long as the denominator is not 0. Alrighty? Then you want to see if your horizontal asymptotes can be crossed. And that can only happen whenever you have more than one vertical asymptote. So step 5, you would only have to do in the case where there's more than one vertical asymptote. Step 6, you want to apply any additional points as necessary. So you may not have enough points to determine where your curves go. So if you don't, just pick some extra points to apply, plug in, and get a value for, so that you can complete your graph, which is step 7, complete the sketch of the graph. Okay, so I know that's a lot of steps. 7 steps. It's not that bad though once you go through it. Just take your time and go through it. So we're going to go through it with an example. All right. Okay, so we're going to graph this rational function, f of x equal to 2x plus 1 over x minus 3. In step 1, we want to find the vertical asymptote. So remember how to find the vertical asymptote. If you don't, make sure you go back and watch another video I created about how to find the asymptotes. Okay, so you want to take the denominator and set it equal to 0, and then solve for x. So if I take the denominator, set it equal to 0, I get x is equal to 3. So this is step 1. That is my vertical asymptote. Now I'm also going to start my graph over here. I'm going to start sketching my graph as I go through each of these steps. So since I have a vertical asymptote at x equal 3, that means at x equal 3, 1, 2, 3, I have a dashed line that goes through there. That is my vertical asymptote. So step 2, I want to find the horizontal or oblique asymptote. So that means I need to look at the degree of the numerator, which is 1, and I called that n in my video where I showed you how to find the different asymptotes. So if you don't know what my n stands for, that stands for the degree of the numerator, and then I call m the degree of the denominator. So the degree of the denominator would be 1. That degree means the biggest exponent. So the biggest exponent in the numerator and the biggest exponent in the denominator. Now in this case, those numbers equal. So that's a case 2. Again, you need to go back and watch the other video if you don't understand what a case 2 is. But in case 2, you end up with the horizontal asymptote at y equal a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. So the leading coefficient of the numerator is 2. The leading coefficient of the denominator is 1. Again, leading coefficient is the coefficient in front of the term with the biggest exponent. All right, so that means that y equal 2, you have a horizontal asymptote. So go to 2 on your y-axis and draw a horizontal line. All right. Next thing I want to do is I want to find the y-intercept, and I find the y-intercept by letting x equal 0. So f of 0 is equal to 2 times 0 plus 1 over 0 minus 3, which is 1 over negative 3, which is negative 1/3. So it's going to cross the y-axis at negative 1/3. So that's before, a little bit before negative 1/2. So I just put a dot at where I kind of guesstimated negative 1/3 to be. Okay, now step 4, I want to find the x-intercept. So I'm going to squeeze step 4 in here, and I do that by taking the numerator and setting it equal to 0. And then I solve for x. So I'm going to subtract 1 from both sides 2x equal -1, and then I'm going to divide both sides by 2. So I get x is equal to -1/2. So that gives me, this one gave me my y-intercept, this one gives me my x-intercept. So what did I do? I took the numerator, set it equal to 0, and solved for x by subtracting 1 and then dividing by 2. So my x-intercept is -1/2. So here's -1, -1/2 is about right there. Because I know this is a rational function, I know it is a curve, that means my curve is going to come through those points. And because those are asymptotes, remember the asymptotes act as magnets, it pulls the graph close to it, but it doesn't attach, okay? So I know what this part of the graph looks like, so now I got to figure out where in the world is my other curve. It could either be up here or it could be down here because it's a function. So remember, since it's a function, you can't have two curves on top of each other. So it can only go in one of these two windows, alrighty? So step 5, we don't have to complete because we don't have more than one vertical asymptote. So there is no way our graph is going to cross the horizontal asymptote. That can only happen in between two vertical asymptotes. And then step 6, we need to apply any additional points that we need. And we definitely need additional points because we need to know what's going on this side of the vertical asymptote. So this is x equal 3. So I'm going to plug in maybe x equal 4 and 5 and see where those points belong. So I'm just going to use a t-chart. And I'm going to plug in x equal 4. Matter of fact, I'm going to go ahead and put my other points in here. My y-intercept was 0, -1/3. So that's that point right there we have on the graph. And then my x-intercept was -1/2 and my y value was 0. And that's this point we have on the graph. So now I want to plug in 4. Because I want to know what's happening at 4. So when I plug in 4, I get 2 times 4 plus 1 over 4 minus 3. That's 2 times 4, which is 8. 8 plus 1 is 9. And 4 minus 3 is 1. So 9 over 1 is 9. So that means over here at 4, I'm up here at 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4, 9, I have a point right here. So that really lets me know where my other curve is. So my other curve is up here in this window, and I could just kind of finish sketching it, or I could just be on the safe side and plug in another point. So if I plug in 5, I get 2 times 5, which is 10. 10 plus 1 is 11. And then I get 5 minus 3, which is 2. So 11 over 2, that's what, 5.5? So at 5, which is here, I'm at 1, 2, 3, 4, 5.5, which is about right here. So my graph is going down like this. So it eventually comes down, but we know it curves up in that window. So that gives you enough information to be able to sketch the graph. And if you have multiple choice problems, you can look at the graphs and see which one best fits the scenario that you have. So this is how you would graph rational functions. It's a lot of steps, but if you go through step by step, it's not that bad. Alrighty, if you have any questions, if I went too fast, because I know some of y'all say I go too fast sometimes. So if you have any questions, if I went too fast, put them in the comments below, or you can email me. Either way, I will respond. Thank you for tuning in. If this video helped you, make sure you hit the like button. And if you haven't already, please subscribe to my channel and hit the bell so that you'll get notifications whenever I post a new video. Thanks for tuning in, and I will see you in the next video.